Hey Kipsters, today we're going to talk about square roots to fine-tune some things that we've already learned. Take a couple seconds and locate this page in your packet. I'm sorry, I apologize, I copied them out of order, but I want to start here. You can detach your packet if you need. Just make sure you staple it back together by the end of the lesson. Alright, so prompt number 1 asks us to determine the positive square root of 16 if it exists. Then we need to explain our answer. Well, I want to point out for us that we're being asked to determine the positive square root of this number because 16 is what we call a perfect square. And remember, perfect squares are created by some whole number being multiplied by another whole number, and they give us a perfect square. Therefore, we can say the root of a perfect square is a whole number. All right, determine the positive square root of 16. Explain your answer. Yeah, the positive square root of 16 is 4 because 4 times 4 gives me 16. Pretty simple. Let's go to number 2. Determine the positive square root of 4 if it exists. Explain your answer. Positive square root of 4 is going to be 2 because 2 times 2 gives me 4. Let's take a look at number 3. Determine the positive square root of 8 if it exists. Explain your answer. Well, I know that 2 times 2 gives me 4. And I know that 3 times 3 gives me 9. And if the square root of 4 is 2 and the square root of 9 is 3, what does that tell me about the positive square root of 8? Yeah, that should tell me that the square root of 8 is going to be in between the square root of 4 and the square root of 9. That means on a number line, this number would be in between the two integers 2 and 3. Well, which of those integers would it be closer to? Yeah, the positive square root of 8 would be closer to 3. So it could be some number like 2 and 8/10, 2 and 9/10. We could actually get our calculators to verify. What's the positive square root of 8 to the nearest 10th? Oh, we were pretty close. Positive square root of 8 is 2 and 8/10. Determine the positive square root of 3. Explain your answer just like we did before. Well, I know that 1 times 1 gives me 2. And I know that 2 times 2 gives me 4. And I know that the square root of 3 must be in between the square root of 2 and the square root of 4. So that means on a number line, these numbers will be in between 1 and 2. Well, let's use our calculator to verify what the square root of 3 would be to the nearest 10th. Square root of 3 is going to be 1 and 7/10. Place numbers 1 through 4 on the number line below. Square root of 16, the square root of 4, and place the square root of 3 about here, and I'm going to place the square root of 8 about here. Alright, verify that your number line looks like mine, and let's continue working. Numbers 3 and 4 are what we call imperfect squares. Imperfect squares are the most popular irrational numbers that we'll work with in the 8th grade. You can approximate the values of irrational numbers by identifying nearby rational numbers on a number line. For example, the irrational number 1.28437 is between the numbers 1 and 2 on a number line. Since it's closer to 1, a close approximation for this number is 1. If you look at the tenths place, you can get an even closer approximation. The number 1.28437 is also between 1.2 and 1.3. Since it's closer to 1.3, a closer approximation for this irrational number is the rational number 1.3. This should be very similar to the work we did on placing irrational numbers on a number line. Remember, we could go even further to determine that this number 1.28437 would be in between 1.28 and 1.30, and we would get even closer on a number line. Scan over example 1. Make sure you read each step and follow along. Once you feel prepared and understand the solution at the bottom of the page, let's get into some guided practice. Determine the positive square root of the given number. If the number is not a perfect square, determine the integer to which the square root would be closest. Be sure to enter your answers on the screen for credit. All right, well, I know some information about my perfect squares. If I want to find the square root of 169, I'll jump right up to 100. So I know that 10 times 10 gives me 100. That's too far off from 169. I know that 11 times 11 gives me 121. I know that 12 times 12 gives me 144. Close but not close enough. Well, I learned that 13 times 13 gives me 169. Therefore, the square root of 169 must be 13, because 13 times 13 gives me 169. You may not need to run through as many of your perfect squares as I needed to, but make sure you capture your work for at least the perfect square before make sure you capture your work for the numbers before to show your process. If you need help, be sure to look at example number 1 again. Square root of 36. Well, I know that 5 times 5 is 25. Not close enough. 6 times 6 gives me 36. Therefore, the square root of 36 is 6. What about the square root of 45? Well, I can use my work from the previous problem. I'm not quite there at 36, so I'll go ahead and jump to 7. 7 times 7 gives me 49. I notice that 49 is bigger than 45, so that tells me that the square root of 45 must be in between the whole number 6 and 7. Which of those numbers would this be closer to? 7. What is the square root of 45 to the nearest 10th? Square root of 45 to the nearest 10th is 6 and 7/10. Try number 8 on your own. And continue with the rest of the problems. Be sure to turn in your packet when you're finished.